Now, next topic, that is magnetic field, Lorentz force. Now, see, we already discussed this thing. When any static charge is in the electric field E, the force acts on it, that is Q into E. So we can write the electric force on charge Q in the electric field E, that is Q into E. Similarly, when any charge Q is moving in the magnetic field, the force acts on it, and that particular force, that is called magnetic force. So if any charge Q is moving in the magnetic field B with velocity V, then the magnetic force act on it, that is given by the equation F magnetic, or we can write Fm, that is Q into V cross B. So here the magnetic force that is represented by equation Q into V cross B means we can understand this thing here. The direction of the magnetic force on the moving charge, that will be perpendicular to both the velocity and magnetic field. And we can fix the direction of the magnetic force with the help of right hand screw rule. Say, electric force that is always in the direction of electric field, okay, because F, that is Q into EQ, that is scalar quantity. So whatever is the direction of electric field, that will be the force on charge Q. Clear? And if the charge is negative, then the force that will be in the opposite direction of the electric field. But here one can fix the direction of the magnetic force by the right hand screw rule or right hand thumb rule with the help of this vector product. Clear to all of you? Now, if electric field and magnetic field both are present and the electric charge is moving in these fields, at that time the resultant force acting on it, that is equal to the vector summation of electric force and magnetic force. So we can write the resultant force F, that is electric force, that is Q into E, plus magnetic force, that is Q into V cross B. So resultantly we can write the resultant force on the electric charge QF, that is Q into E plus V cross B, and this particular resultant force on the charge Q in the presence of electric and magnetic field both, that is called Lorentz force. That is called Lorentz force. Clear? We already discussed this thing. When any charge Q is moving in the magnetic field B with velocity V, then the magnetic force on it, that is given by Q into V cross B. We also discussed this thing, the direction of this resultant force, that is in the direction perpendicular to both V and B. If we think about the magnitude of this particular force, then we can write the magnitude of magnetic force, that is QVB sine theta, where theta is the angle between V and B. Now here we can discuss some special cases. Suppose the charge is moving with velocity V in the direction of magnetic field. So if velocity is in the direction of the magnetic field, it implies that V and B both are parallel. So theta, that is 0. In that case, we can write here sine theta, that is sine 0, sine 0, 0. So magnetic force will be 0. Or if the charge q is moving with velocity v in the opposite direction of magnetic field. So if v and b are anti-parallel, then the angle between v and b, that will be pi. Okay, so sine theta, that is sine pi, again it is 0. So here we can conclude like this: if the velocity of the charged particle is along the direction of the magnetic field, either in the direction of the field or in the opposite direction of the field, the magnetic force acting on it, that will be equal to 0. Clear? Now let's derive the unit of magnetic field B. Say, from this equation of the magnitude of magnetic force on charge Q, we can write B, that is equal to Fm upon Qv sine theta. Now unit of B, that is equal to unit of force, that is Newton, upon unit of charge q, that is coulomb, and of v, velocity, that is meter per second. So that second is written here in numerator. Now this Newton second upon coulomb meter, that is called Tesla on behalf of the name of scientist. This unit is called Tesla. Okay, so we can say Tesla, that is the SI unit of magnetic field B. Its small unit, it is non-SI unit, that is called Gauss. And 1 Gauss, that is 10 raised to minus 4 Tesla. Now from this unit, you can prepare the dimensional formula also. Say, dimensional formula of magnetic field B, that is equal to dimensional formula for force, means of Newton, that is M1 L1 T minus 2. For second, T1. For Coulomb, means for charge Q, A1 T1. And for meter, you can write L1. So this T1, T1 cancelled. This L1, L1 cancelled. So finally you will get M1 L0 T minus 2 A minus 1. That is the dimensional formula of magnetic field B. Clear?